All right, I hope your homework went well. All right, you did confidence intervals last time for proportion. Now what we're going to do now is we're going to do confidence intervals for mean. Now as far as working the problems, I'm going to give you a fair amount of background information that you don't really need, all right, but I want you to understand what the calculator is doing. But basically you're going to do it just like you did last time. You're going to go over to stats and go over to tests, but you're going to choose a different test to use. But the calculator is going to do all of the work, and all you're going to do is take the numbers in the parentheses and place them in the blanks. So let's go look at the PowerPoint so I can kind of talk you through it. Now this one's going to deal with mean. All right, so let's kind of go back up here at the beginning, all right? So we've got confidence interval for mean, and they're going to be worked similarly to confidence intervals for proportion. So again, you're going to have a symbol between two blanks. But now remember what I told you last time on the last video. You need to make sure you use population symbols. So if it tells you to write a confidence interval for proportion or percent, you put a P between two blanks. But like this video, if it tells you to write a confidence interval for mean, then you put a mu between two blanks. Now, do you understand why it's a mu and it's not an X bar? We can't use X bar because that's a sample symbol, and confidence intervals always use population symbols. Now, here's what the calculator is really doing. The calculator is taking a sample mean and subtracting a little bit of error and a sample mean and adding a little bit of error. Just like last time, it took p half because that's the proportion of a sample and subtracted error and added error. Well, since we're doing mean, it's going to do the same thing for mean. So the calculator is going to do all the work. So when you see that you're doing confidence interval for mean on your paper, you write a mu, not an X bar, but a mu between two blanks. And the calculator is going to give you the number to put in the blanks. Now, here's some background information, though, I do want you to understand. There are two symbols for standard deviation, S and sigma. Now, you know which one is which. You know that sigma is a standard deviation of a population and S is a standard deviation of a sample. Now, depending on which one they give you, you would pick two different things on your calculator. If they give you sigma in the word problem, you're going to choose Z interval because that's going to use a normal curve. If you know S, the standard deviation of a sample, you're going to use T interval. Now, I think every problem in your book does the second one. Because think about it, you're trying to predict the mean of a population. Well, I mean, how often would you know the standard deviation of a population and not know the mean? I mean, that might happen occasionally, but not very often. Most of the time, if you don't know mu, you don't know sigma. So I think exclusively in your homework, you're going to keep choosing T interval. So that's the one I want to kind of zero in on this video, is this T interval. Now, this is the background information that I want you to understand. A Z interval uses a normal curve. Now, you know what a normal curve is, but a T interval uses something called a T distribution. Now, a T distribution was developed to be used with pretty small samples. Now, it's very similar to a normal curve. If you looked at it, you might think it is a normal curve because it's bell-shaped, the mean's in the middle, but the percentages are different. They're not going to be 68% within one standard deviation, 95, they're different, okay? So, but it is a bell-shaped curve that is symmetric. So if you looked at the picture, let me kind of show you what I mean by when you look at the picture. I've kind of got the two kind of superimposed on each other. This black one is your regular normal curve, okay? So this black one is your regular standard normal distribution. Now these other two are T distributions. Now notice how it looks. See, it's a bell-shaped curve, but it's not as high as a standard normal curve, so the percentages are different. And the T distributions you usually use when you have a small sample space, okay? Or a small sample, not sample space, a small sample, and you know S. In other words, sigma, the standard deviation of the population is unknown, you know S. But notice, if the sample sizes get more, as they increase, this T distribution gets closer and closer to being a normal curve. So we'll talk about degrees of freedom in a second, but if your sample size had 11 things in it, you'd have the red curve. If your sample size jumped up to 21 things, then you would have the blue curve. Now, if your sample size is more than 30, this T-curve is almost exactly like that normal curve, okay? So that's just a little bit of background information about this T distribution. Now, I'm going to go pull up a couple of other background things for you. There's something your book's going to talk about if you read the section called Degrees of Freedom. Now, you don't have to do it to work the problems, but in some other courses, they may talk about degrees of freedom. So I do want to just explain what they're talking about. It's how much wiggle room you have with your data. So degree of freedom is the number of sample values that can vary or change after certain restrictions are placed on that data. Now, what in the world am I talking about? I'm talking about this. Here's an example. If you knew that you had 8 tests in a class and your average came out to be 90, that means that when you added the 8 grades up, you must have gotten 720. Now, why? Because 720 divided by 8 gives you 90, okay? So that means 90 times 8 gives you 720. So for you to divide and get 90 at the end of the division, and you know you're dividing by 8, the sum of those 8 test grades would have to be 720. So if your first test grades were an 86, and a 98, and a 97, 84, 94, 88, and 93, you could add those up, but the last test grade would have to be a certain number for you to get 80 for the average, because you would have to add whatever number makes this sum add up to 720. So the first 7 numbers can vary. You might have an 80, 100, a 60. You might make a bonus and have 110. So the first 7 values could vary, but that 8th test grade would be whatever it took for the sum of all 8 to be 720. So that's an example of where your sample, basically, your degree of freedom would be your sample size minus 1. And that's what this T distribution is going to use. So if you had 11 in your sample, your degree of freedom would be 1 less than that, it would be 10. If you had 35 in your sample, your degree of freedom would be 34, because your sample size of 35 minus 1 gives you 34. Now the calculator is going to do all that for you, but still I want to make sure just that you understand sort of when you're reading what that notation means. Let's go look at something else. Now let me clear that blue mark that I made so it doesn't bother you. Okay, so I'll clear that off. Here's what's going to happen when you're doing confidence intervals when S is known, and that's really all we're going to talk about on this video. You're going to go to stat on your calculator like you did before for confidence interval. You're going to go back over to test like you did for confidence interval. The difference is you're not going to be looking for one prop Z int, because you're not doing a proportion interval, you're looking for a T interval. Now, why are we picking T interval? We're picking T interval because we know S. If you were to know sigma, you would pick Z interval, but we're going to stick with T interval. Now, when you scroll down to T interval and you hit enter on your machine, you're going to have 2 choices, data and stats. You're going to go over to stats, and you're going to enter these values in. The mean of the sample, the standard deviation of the sample, the N, your total, how many were you sampling, and your confidence level. Now make sure that confidence level, like last time, is in decimal form. So if it were 95% confidence level, you'd put 0.95, not 95. But this time, because you're doing confidence interval for mean, you're going to put a mu and then between 2 blanks. And the calculator tells you the numbers to put into the blanks. So let's go work a couple just to make sure that you understand what I mean when I say those steps. Have your calculator out. So you might want to freeze the video, copy that down, and then pull your calculator out so you can work this one with me. Here's the way the problems are worded. In a test of weight loss programs, 35 adults used the Atkins program. After 12 months, the mean weight loss was 2 1/1200 pounds, and the standard deviation of that sample was 4 7/75 pounds. So construct a 95% confidence interval estimate of the mean weight loss for all such people. Now here's what you need to get in the habit of doing. so that you don't make a mistake when you're taking your third test. Anytime it says construct a confidence interval, find out of what and underline it. Because on your homework for last week, it said construct one for proportion. So you put a P between two blanks. This time it says mean. So you would go on your paper immediately and put that mu, and you would have a blank on the left, and you'd have a blank on the right. And then here's what the calculator is going to do to get you the number to put in those blanks. Now, I've got to decide whether I know sigma or S. Is this standard deviation coming from a sample or from a whole population of everybody that's on a weight loss program? Well, see, this 4.75 came from this sample of 35. So that's how I know that 4 7/75 is S. So sometimes it'll say S equals, but sometimes it expects you to read the problem and decide for yourself. So if that value comes from a sample and it's a standard deviation, it's S. So that's how I know to choose T interval. So I go in to my calculator and scroll down to T interval. My mean is 2.12, so they just told it to me in the problem. My standard deviation was 4 7/75. My total in my sample was 35, and my confidence level was 95%, so I changed to a decimal. So when you hit calculate, these are the two numbers that come up on your calculator. Now, if you just box this parenthesis, I'm going to count off. Don't be lazy. So this is the number that goes in the left blank, and this is the number that goes in the right blank, and this is what I would want to be boxed for your answer. So the average weight loss on this Atkins program was between, look what this says, less than a pound and about 3.8 pounds. So yeah. I am sorry, I'm not dieting for a year and giving up cake if my average weight loss is like less than 4 pounds, but every man for himself. Okay, so let's go work another one where you have to do just a little more work, but not much. Look at this problem. Listed below are the caffeine levels, like for a 12-ounce canned drink, obtained from 18 cans of soda. So they grabbed 18 cans of soda and found how much caffeine was in each. So the first can had 34 milligrams and 34, another one had 45. Some of them were caffeine-free drinks. That's why there's a 0 there. So there are my 18 different caffeine levels in milligrams for a 12-ounce drink. So it says construct a 90% confidence interval estimate of the mean caffeine levels for all such soda brands. So remember what it says. Construct a confidence interval estimate. I'm going to underline of what? Of the mean. So that's how I would know to put me on my paper between two blanks. And then the calculator is going to figure out the blanks. Now I do the same thing. I'm going to try to go over and choose T interval, but remember I need this data to enter, and they didn't give me that data. So you learned how to do this for test 1, but let's review real quick just in case. You're going to enter all 18 values in a list. All right, remember how to do that. You go over here to stats, okay? And then you go to edit and enter those 18 numbers in that list. Then you go back to stat and go over to calc and make sure you choose one variable stats. And when you do, it'll give you these values. And you can kind of round where you want to, but since these numbers are whole numbers, I'd at least round to one more place of accuracy, so at least the tenths. So you enter the values that you got. Confidence level was 90%, so that's why I put decimal 90. When you hit calculate, this is in the parentheses. That's the number on the left, that's the number on the right. If you know it's milligrams, put milligrams on there. Now look, I'm going to do the same problem, but instead of it being 90% confident, I want to do it 99% confident. So the same problem, all I'm doing is changing that 90% to 99%. I want to be more confident that I'm correct. So if I do that, I'm going to do the same thing. All those numbers are entered in on the list. This is still the mean, the standard deviation. Only thing I would change here is I would change this 0.90, of course. I would have to change it to decimal 99. And then these are the two numbers that would come in my parentheses. Now, I did this to show you something. Remember last time I told you, as you get more confident, that interval has to widen. You get more wiggle room. So look what happens. When my confidence level, when I was more sure that I would have the correct answer in my range, my confidence level had to increase. See, these two numbers are further apart than these two numbers. So as your confidence level increases, your interval has to widen. So I just wanted to kind of reiterate that to you. But that's what you're going to do to work these homework problems. You just basically choose a different test. You don't do 1 prop Z int, you do T interval to work these problems. All right, so try them. If you have any trouble, let me know. I don't think you're going to have any trouble with them at all. I think everything's fairly simple. So if you do have trouble, email me and we'll figure out how best to get you back where you need to be. Thanks.